Okay, to begin the disc diffusion test, we need to pour a Petri plate with melted nutrient agar, which is sterile. So, we've done this before. We're going to grow bacteria on this Petri plate and see which chemicals can inhibit or kill those bacteria. So here is our nutrient agar Petri plate, nice and cooled and solidified. We're going to streak it with a broth culture of E. coli. So we've got sterile swabs. What we want to do is create a lawn of bacteria growing all over this Petri plate. Okay, so we just dip the swab in. The cap back on. And now zigzag it. Streak the entire surface. I'm just gently inoculating the entire surface with bacteria. Okay. I'm going to flip the Petri plate upside down and label it 1, 2, and 3. Number 1 is going to be our antiseptic, which can be applied to living tissue, and I chose Scope mouthwash. So I'm going to put some of that on place number 1, see if it kills bacteria. Number 2 is going to be our disinfectant. I chose Lysol, so I'll get Lysol on position number 2. And position number 3 is going to be an antibiotic. Now this is azithromycin, and it already comes impregnated on these little discs. So what we have to do is sterilize these forceps over the flame, pick up a disc, put the mouthwash on it, and then put the disc on number 1. Repeat that with Lysol, and then we'll sterilize these, grab one of these discs of azithromycin, put it on spot number 3. But how are we going to sterilize these forceps? Well, we can't just hold it in the flame because it'll burn our fingers. So we're going to use alcohol on the tips of the forceps and start our Bunsen burner. And now watch this. If I put the forceps in there, as the alcohol burns off, it sterilizes the forceps. So I open this with the sterile discs, grab one disc, and then take our mouthwash and dribble it, shake off the excess. Now I put this on position number 1. What's going to happen is the mouthwash is going to diffuse around in the agar, and if it kills bacteria, you'll have a clear zone around the disc. That'll be called a zone of inhibition. Alright, so now let's do our Lysol. Again, dip in alcohol, sterilize, grab a disc, okay, there's our Lysol. Dribble it on the disc, shake off the excess. Now put this in position number 2. Press it down, let that soak in. Now for our antibiotic. Sterilize the forceps and grab one of these discs. Okay, that's azithromycin, 15 micrograms. Put it in position number 3. And sterilize the forceps. And now we're going to put this in the incubator, come back and see which chemical was the best at inhibiting or killing bacteria. Alright, you know the drill. Put it in the incubator, set at human body temperature, inverted, and we'll come back and see what it looks like tomorrow after 24 hours. Alright, let's check out our disc diffusion results. Okay, so the bacteria grew. Let's take it back to the desk, give this a closer look. Okay, so it looks like disc number 1, the bacteria grew right up to the disc. So that was mouthwash. It did not inhibit bacteria. Now, disc number 2, I don't know if you can see, but there's maybe a couple millimeters around that disc. Okay, but look at number 3. Okay, number 3 has a clearing that extends all the way out to there. So how do we compare these 3? We're going to measure them. Okay, so here's our ruler. Again, we're measuring in millimeters. What we're measuring is from the edge of the disc out towards the edge of the clearing. Okay, so this one, number 2, that's only 3 millimeters. Now, number 3 is azithromycin. That's the Z-Pak antibiotic. And this one is about 10, 11, 12. Okay, let's look at those data. So again, our first disc was an antiseptic, which was mouthwash. This had 0 for a zone of inhibition. The disinfectant, Lysol, had about 3 millimeters zone of inhibition. And azithromycin, the antibiotic, that was about 12. Okay, so we care about the zone of inhibition. Based on these results, which do you think the best antibacterial chemical was? Yeah, azithromycin, which is an antibiotic, so that's really not a big surprise. What surprises a lot of people is that mouthwash is not very effective at killing bacteria. It makes your mouth smell better, it tingles a little bit, and it might kill some bacteria, but you see it's not very good at having an effect, at least on E. coli, which is the bacteria. Lysol, you might think, was very good. One of the things that happens with Lysol is that it interacts with the organic matter in the nutrient agar, and so it has reduced efficiency. And so you've got basically moderate antibacterial properties with Lysol in this situation, and the best was definitely azithromycin. Okay, here's another example of the disc diffusion test, and you see the clear zone is dark. So which of these, 1, 2, or 3, is the best antimicrobial chemical? Well, 2 has the bacteria growing right up to the disc, so that didn't have any effect. 3 has a little zone of inhibition around it, but number 1 in this case has a much larger zone of inhibition, the clearing, and so according to this disc diffusion test, number 1 is the best antimicrobial chemical.